So on Wednesday, we talked about square roots of perfect squares, like the ones in the A section on the notes. So just real fast, as a quick review, on number 1, what is the square root of 49? 7, good, thank you. And what's the square root of 1? 1. What is the square root of 225? Hopefully after bingo, I was hoping this would be easier to recognize the bigger numbers. What's the square root of 225? It has a 5. It's not 25. It's 15. Good. Yeah, it definitely has to end in 5, right? Because the number has a 5, and that's the only way you could square something and have a 5. So good, it's 15. And then what's the square root of 169? Not 18. So if I squared 18, the last number would be a 4, because 8 times itself is 64. 13. Perfect. Okay, so those are perfect squares because they simplify completely. Today we're talking about squares that don't do that, and I'll show you 2 different methods, okay? I'm going to show you one method that's like a long method, but as long as you do it right, it will give you the correct answer every time. Then I'll show you a faster method that uses perfect squares. And it's faster, but it's not necessary. So I don't want you to feel like you have to master the faster method. You don't. You can do the long, slow one and get this right answer. And it's just not, one is not better than the other. So for this first one, we're going to do the square root of 50. And you probably remember in the past doing a factor tree when you're trying to do square roots, right? You would look at 50, and to factor means to break a number down into the other numbers that multiply together to get the original number. So like 4, when you factor 4, it's 2 times 2. And when you factor 6, it's 2 times 3. And the 2 and the 3 are what we call factors. So you break 6 into its factors of 2 and 3. I feel like I'm just repeating the same stuff. So that's what we're going to do here on the 50. We're going to first break it down into its factors. The smallest number that goes into 50 is 2. And so I can say, all right, 50 is 2 times 25. And the 2 can't break down anymore. It cannot factor, so I'm just going to leave it alone. But 25 is 5 and 5. And once you get here, because 5 and 5, they can't break down anymore. So what I've just done is rewritten 50 as 2 times 5 times 5. And I'm looking for a pair of 5s because that's what square root means. It means there really could be like a 2 here. It's a square root. What 2 things multiplied together give you 25? And so you find a pair of 5s, like there's a pair of 5s here, and you bring 1 5 out. And now your answer is this, 5 square roots of 2. And this is called simplifying the radical. And the second method for doing that is this. That very first step right here, when I factored and had 2 times 25, if I could notice that 25 is a perfect square, then I could have done this instead. I could have said, all right, I need the square root of 2 times 25. The square root of 25 is 5. So I'm going to simplify it, and I bring the 5 out. The 2 stays inside because it's not a perfect square. And then that would give me 5 square roots of 2. The same answer. So the first method is you factor or break down the number as much as you can. And then you look at all of them and you circle pairs that you can simplify. The second method is you factor until you find a perfect square, and then you can stop factoring and just simplify the perfect square. All right, so let me walk through 6 with you as well, and then I'll leave you alone to try some by yourself. So 6, we're taking the square root of 27. Tell me the smallest number that goes into 27. Even smaller than 18. 9, even smaller than 9. 3, yes, let's start with 3. So 3 goes into 27 9 times. Which of those numbers can I factor some more? Which one can I keep going? The 9, right? So 9 can factor into 3 times 3. And I can't break those down anymore. So this is where I'm going to stop for this method. So I'm going to use those to rewrite it like this. So 27 can be rewritten as the square root of 3 times 3 times 3. And the square root is the opposite of squared. And squared means I have 2 things. So I'm looking for a pair of the same stuff. Now there's only one pair of 3s here, so I can only, that simplifies as 1 3 on the outside. And the third 3, there's too many 3s in this problem, stays inside. Because you can only pull out a number if it's got a second thing to go with it, if it's a pair. And here's how I would have done that on the second method. I would have stopped right here at this step. Oops, I made it black. At the 3 times 9. And I would have done this. The square root of 3 times 9. 9 is a perfect square, so this simplifies to 3. Now I have 3 radicals. I want you to try the rest of the problems, and then we're going to talk about it. We'll talk about all of them. What time are we out of here? 12:50. On square root of 72, you start by factoring, and you have 2 times 36. And then the 36 can be factored lots of different ways from here. So your numbers might look different from someone else's. Maybe you saw 36 and you thought, 6 times 6. But the 6's can still be broken down. Each of those is 2 times 3. And you want to keep factoring until you cannot factor anymore. Like all the numbers are as simple as they get. And that's where we are here. We got 2, 3, 2, 3, and then we still have this 2 from the beginning. So then when I go compare everything together, In the radical, I might have 2 times 2 times 2, and then the 3. And I'm looking for pairs. So I have a pair of 2s that I can bring out. I have a pair of 3s that I can bring out. And I forgot to remind you about what do you do with those 2 numbers that you bring out? What math operation is it? And it's multiply. So the 2 and the 3 you bring out, you multiply together, you get 6. And then you just have that one lonely 2 left over in the radical. And then for the second method, this is like a ninja method, if you want to be a ninja about it. I would have stopped right here. And I would have noticed that 36 is a perfect square. So if I want to do that method, it would look like this. The square root of 2 times 36. And I know that the square root of 36 is just 6. So I'll just pull it out right there. And that would have been faster. But do we care that it's faster if we like the other way better? No, we don't care. Whichever one gets you the right answer is the method that you want to use, whichever one you're more comfortable with. All right, so put in the chat for me what you got for number 8, the square root of 32. And just use RAD, rad, instead of typing in a radical. Unless you need time, raise your hand if you need time for that one. Okay, go ahead. I'll give you another moment. Let me erase this. I kind of wrote over it. Erase that. Dang it. So square root of 32 is 2 times 16. And maybe you did 16 is 4 times 4, or maybe you did 8 times 2. Let's say you did 8 times 2. Then from there, you would have said that, because you can't stop yet, you have to keep going, because 8 can be factored more. So 8 is 4 times 2, and then 4 is 2 times 2. And now that's as far as we can go. And so here's all the 2's we have. There's like 1,000. And so then when you write that under your radical, and the only reason I write it under the radical here is it helps me keep everything organized. Because sometimes I'll see students, especially on these longer trees like this, they'll just start circling stuff and they'll end up missing stuff and they lose stuff. So I like to write everything out left to right. It's easier to group stuff. Like I just said stuff. Like so now I'm looking for pairs of 2's. Here's one pair of 2's. So for every pair, you pull out just one. Because really that means 4, and you're taking the square root of 4, which is 2. And then there's another pair of 2's here, which I'll bring out 1. And then every time you pull out more than one number, you multiply those together. So I have the 2 times 2 that I pulled out, and the 2 that's okay. Raise your hand if you got that one right. Okay. Raise your hand if you tell me 1 or 2 if you got that one right using the first method or the second method. First method or second method. I can't even see Joseph. I just saw his fingers. Put his fingers up to tell me which method you got. Okay, thank you. If you were using the second method, the faster one, the ninja method, you can stop right here because 16 is a perfect square. So that would have looked like this. 2 square roots of 16 Um, wait, that's not right. Did I do something wrong? Oh, wait. Yes, I did. Sorry. That doesn't work out. This is what I meant. Square root of 2 times 16. This is better. And then square root of 16 is 4. So this would have simplified. You would pull 4 out. And then that would get 4 radical 2. All right, so finish up the last 2 problems and put done in the chat for me when you're done, please. And then I'll go over it. So finish 9 and 10 and put done in the chat when you're finished. So there's my work, both methods, in case you needed to compare yours. Does anybody need help on those problems? All right, what we're going to do now is you have your practice worksheet that you either were able to print out or you can just copy the problems onto notebook paper, and you have the rest of class to work that. It is for a homework grade, for a self-check. I don't think I made the assignment in your Google Classroom yet. So I'm going to go do that while you're working. Let me shut down this Smart Notebook.